Hello and welcome to Algebra 1, Chapter 5.1, and since this is the first section in Chapter 5, an introduction to Chapter 5, Chapter 5 is solving systems of linear equations. So remember, linear equations graph lines, and we're going to learn what a system of equations is. So 5.1 is graphing systems of equations. And so what is a system of equations? A system of equations is two or more equations that are grouped or graphed together. So instead of just looking at one equation, we're going to be looking at two. The solution, this is important here, the solution to a system is any ordered pair that is a solution to every equation. In other words, it's going to be, or it could be, where they cross. So remember, on a given line, if this is my line, every point on that line is a solution to it. So a solution to a system is an ordered pair that's a solution to every line. So if I have another line and they share that point right there, that's the solution to the system. So there's three ways that you could have two lines on a graph. Okay, so if you have two, and remember, lines are always straight. So the first instance is that they could intersect. So here in the first box here, we have two lines that intersect, and they intersect at a point. So there is exactly one solution, and that point right there is that one solution. And we say if there's exactly one solution, that the system is consistent and independent. Okay, so consistent means they intersect, and independent means they intersect once. So let's look at the second case. The second case could be, what if they're the exact same line? And so you only see one line here, but that's because they're the exact same line. So if they're exact same line, we say that there are infinitely many solutions because they share every single point. So it's consistent because they intersect, but it's dependent this time because they intersect everywhere. And our last case that we could have is, what if they are parallel? So they are never going to intersect. There's going to be no solution. In this case, they're considered inconsistent because they do not intersect. So those are the three cases that we're going to be looking at. So we're going to use the graph here, and these are already graphed for us, to determine whether each system has no solution, one solution, or infinitely many. Alright, so let's color code these. We're going to have red and green, and let's find these lines. Y equals negative x plus 1. Y equals negative x, so this, let's see here. Here's my red line, right there, and negative x plus 4. Here's my green line, and what do you know about those two lines? They are parallel. How do you know they're parallel? You could find this out without even graphing it. They're parallel because they have the exact same slope. They each have a slope of -1. Okay? So they're parallel because they have the same slope, and if they're parallel, they're never going to touch, and they are going to have no solution. Alright, so the other case, we're looking at 3x minus 3y equals 9, which is right here. And we're looking at y equals negative x plus 1, which is right here. So those two lines intersect once, right? Here's one, there's the other. They're going to intersect once, and so there is one solution. So why don't you pause the video and see if you can answer these two. For the first one, I got infinitely many, that they are the same line. I got them to be this line right here. And for the other one, I got them to have one solution because you have your one line coming in right here and your other line coming in down here, and they are going to cross once. Okay, so that was if we were just looking at a graph. The next thing we want to do is we want to solve the system by graphing. And so to do that, you're going to graph both equations, on the same coordinate plane, and you need to very carefully find exactly where they cross. Okay, do not guess where they cross. You need to find exactly where they cross. So we're going to graph these two lines. This is pretty important that you're using slope-intercept form here. Okay, so I'm going to write out my first equation. And remember, to get it in slope-intercept form, I want the y by itself on the left, and then it's going to be equal the x term, and then the constant. Alright, so I'm going to move my 2x over. That cancels. Negative y equals negative 2x minus 3. Divide by negative 1 because I don't want to have a negative y. Okay, so here's this line. So I'm going to go ahead and graph this line. I'm going to start at 3. And I'm going to go up 2 and over 1. Now, I'm going to suggest I'm going to do some extra points because I have no idea where they cross. And I'm not going to draw in my line yet. Okay, so the reason is that if I want to find exactly where they cross, we don't always draw our lines exactly where they should be. So I'm just going to leave those points there. And then come back to the other line. That's negative 12. And so I'm going to subtract 8x. Negative 4y equals negative 8x minus 12. Divide by negative 4. Y equals 2x plus 3. Well, look at that. Okay. What is happening here? Those are the exact same line. If I start at 3 and I go up 2 over 1, it's the exact same line. Okay. So here's the deal. Solve by graphing, you have to graph it. So I need to go ahead and draw in my line. And then how many solutions are there? There are infinitely many solutions because they ended up being the same line. Okay, let's try another one. Okay, so same deal. We're going to graph these. So I'm going to put them into slope-intercept form. So we're getting some practice here on slope-intercept form. Divide by negative 2. So y equals, that is 1/2 x. Negative over negative is a positive. Minus 2. So I'm going to start at negative 2. Go up 1 over 2. Up 1 over 2. And again, I don't know where they cross. And so I'm just going to lay out some points. Or I can go down 1, back 2. Oh, that was only down 1, back 1. Let's try that again. Okay, so there's my first line. So my second line, I'm going to put it into slope-intercept form. Again, that's 1/2 x plus 1. So start at 1, go up 1 over 2, up 1 over 2. Okay, well, what's happening? They're parallel. And again, how do you know they're parallel? They have the same slope. Alright, so solve by graphing. You have to have them graphed. So finish graphing them. You will get points for graphing them. And then what's your answer? In this case, it's no solution. Okay, let's do another one. We got this one and then a word problem and we're done. So, first step, put them into slope-intercept form. And if you have a place that you need to write down some steps, That's always a good thing to have your steps written out. So step number 1, put equations into slope-intercept form. So there's that one. So I'm going to start at -2, and my slope is 1 up 1 over 1. Okay, then I'm going to look at the other one. Oh, and that's a misprint. I think that should be equals 9. Yeah, we'll see where that takes us. Alright, so plus 9, divide by 3. Alright, so there's my slope-intercept form. So I'm going to start at 3, and I'm going to go down 2 over 3. 1, 2, 3. Oh, look at that. Right there is where they crossed. And because I counted out my points, I was already there waiting for me. Okay, so I did another one just so I could have it to draw in. You have to draw in your lines. No lines, no credit for lines. So we're going to draw in our lines. And then this time we have one solution, and the directions say if it has one solution to name it. Remember from one of the first slides that the solution is the ordered pair. Okay. 3, 1 is your solution, and you have to write it as an ordered pair. It's the point where they cross. Alright, so Tyler and Pearl went on a 20-kilometer bike ride that lasted 3 hours. Because of the steep hills on the ride, they had to walk for most of the trip. Their walking speed was 4 kilometers per hour, and their riding speed was 12 kilometers per hour. How much time did they spend walking? So the first thing we need to look at is notice this is talking about a distance. It's talking about a rate. Speed is a rate. And it's talking about a time. And so if they're talking about a distance, rate, and time, you should be thinking of the equation distance equals rate times time. And we have two situations here. We have our walking situation and we have our riding. So we need to write two equations because we have two things happening. We need to write an equation where we are walking, and we need to write an equation where we are riding. Okay, so let's do walking first. So do we know the distance that we walked? We don't know the distance that we walked, so let's call that y equals. Alright, and then our rate that we were walking was 4 kilometers per hour times our time that we walked. And do we know the time that we walked? We don't, so let's just call that x hours. So if that was walking, for riding, if we walked y kilometers, how much did we ride? We rode 20 minus y kilometers. Okay, so if I walked 1 kilometer, I rode 19 kilometers. Or if I walked 5 kilometers, I rode 15 kilometers. And notice then they will always add to be 20. Okay, the speed of which I rode was 12. And the time that I'm not sure, but I know they have to add to 3, so I'm going to do 3 minus x for however long I was walking, then the rest of that was riding. So there's your equations, okay? And so we're going to graph these and figure out where they cross, and then that's going to be our answer here, and that will actually give you how much not only time did they spend walking and riding, but also the distance. Okay, so the first one starts at 0 and goes up 4 and over 1, up 4 and over 1. Okay, so there's our first line. The second line needs to be put into slope-intercept form. So we're looking at 36 minus 12x. I'm going to move the 20 to the other side. I'm going to do some rearranging here. Negative 12x plus 16. We're going to divide everything by negative 1. So we're going to get 12x minus 16. Okay, so we're going to start way down at 16, which is off my graph. But that's okay. So if I come up 12 and over 1, let's see, from negative 16 up 12 would be negative 4 and over 1. I think we're going to start there. So then I go up 12 again, which would be up to 8 and over 1. Oh, look, right there is where they cross. Okay, I'm going to go ahead and draw in my lines. I know yours are much straighter than mine. There we go. Okay, so this point right here is where they cross, and that point is 2, 8. And x stood for time, so this is time and distance. So how much time did they spend walking? And notice for walking we used x and y, right? So they were 2 hours walking. And we actually know a lot more here. We also know they spent 8 kilometers walking, which you could then go figure they spent 1 hour riding. Okay, because you could do 3 minus 2. They're 1 hour riding, and they spent 12 kilometers riding. Okay, let me know if you have questions. The blog isn't working very well, but you're welcome to email me or come in before or after school. We'll see you later.